Okay, so we are up to part 4 of this lesson, all about signed area. That was the first question we went through. That was the second question we went through. That was the third question we went through. And now we come to the fourth question right here. So you should probably try to pause the video and try it for yourself and then check back here once you've done so. So how are you going to answer this question? It says find the area bounded by the curve y equals x cubed minus x and the x-axis. So the first thing I need to do, I need to determine which area is above and below the x-axis for me to determine what is the positive and negative area. So that means I'm going to have to sketch this right here. To do that, I'm first going to factorize it. So I'm going to get y is equal to, I can take out a common factor of x, which is going to leave me with x squared minus 1. Having done that, to solve for its x-intercepts, so to solve for x-intercepts, what do? You let y equal 0. Let y equal 0. We've done that a million times. So that means we're going to end up with 0 is equal to x squared minus 1. Now we can say, well, according to my null factor theorem, x is going to be equal to 0 and x squared minus 1 is going to be equal to 0. So based on this, x squared is going to be equal to a positive 1, then x is going to equal plus or minus the square root of 1, so therefore x is going to equal plus or minus 1. So my x-intercepts are going to be that, and it's going to be that. So now I can come over here, and I can say, all right, I'm going to have an x-intercept at 0, and I'm going to have one at negative 1, and I'm going to have one at positive 1, just like that. And I also know that my y-intercept is just going to be at 0, but that's really not going to affect us. All right, so let's now try to draw this. This is the hardest part of the job right here. Are you ready? So we're going to go up and, whoop, I didn't even make it there. Ready? We're going to do that. Then we're going to go up like this. Perfect, that isn't too bad. Then we're going to go down like that. Let's see if we can do that a bit better. I'm going to do like that, and then we're going to keep on going up. All right, that's halfway decent. I'm pretty proud of myself right now. So, having drawn that, we need to find where the area bounded by this curve is with the x-axis. So obviously this is my x-axis right there. So I'm obviously just looking at this region right there, this part right here, here and here. Those are the parts bounded by the curve and the x-axis. So let's just label these. These we'll call A1 and A2. And let's come over here. And you can probably just by looking at this immediately tell me what the answer is going to be, or how to go about it. I think you could tell me that the signed area, so that's when you consider the sign of each of them is going to be 0, because these are going to be the same area. But what is our total area is going to be? That's going to be a bit trickier. To do this, what I'm going to do is I'm going to treat it as one thing in terms of doing this. So I'm going to go find the integral between -1 and 0. So I'm going to put my bigger number here, smaller number there, then go x cubed minus x dx. And then I'm going to put my other integral here like that. And that's going to be from 1 to 0. Then it's going to be x cubed minus x dx. Now, if I want to kind of, as I said, treat this as one thing, I'm going to have to put a negative there. And the reason for that is because my A2 value right here is going to be negative. And I know it's going to be negative because it's below my x-axis. So by drawing this, it tells me that I'm going to have to put that negative right there. Okay, because this is going to produce a negative, and the negative and negative will come a positive, so I can figure out what my total area is going to be. So let's write total area here, total area. All right. Let the fun begin. We are going to anti-differentiate this, which is going to leave me with x to the power of 4 over 4 minus x squared over 2. Then I'm going to do that, and then I'm going to put in my terminals. Then I'm going to go subtract, and I'm going to do it again. My antiderivative is, of course, going to be the same because it's the same function that I'm dealing with. So I'm just going to copy that out, making sure I'm writing everything down correctly. Then I'm going to have put my terminals in for this one. So 1 and 0, 1 and 0. Having done that, we are now going to sub in our terminals. So I'm obviously going to put 0 in there, which is just going to leave me with 0. Then I'm going to subtract this. When I put 1 in here, 1 over 4 minus 1 over 2. Then I'm going to close that bracket. Then I'm going to close it again. Then I'm going to subtract, and I'm going to open my bracket. I'm going to put 1 in here, which is going to leave me with 1 over 4 minus 1 over 2. And I'm actually going to do something. I'm going to put another bracket in here. People often get confused with the brackets and the negatives with all of this, so just take your time with it and make sure you're doing it nice and slowly. Whenever I see that I'm putting a 0 in there, because there's no constants, I know it's just going to end up being 0. And I might not put that one in a bracket, I might just do that. And then I put a big bracket on the end like that. Having done that, what I can now do is say, all right, right here, what I've left with is negative, and 1/2 minus 1/4 minus 1/2 is going to be negative 1/4. And then I'm going to subtract, and over here, what I'm going to be left with is also 1/2 minus 1/4 minus 1/2, which is going to be negative 1/4. Put that in brackets right there. Come down here. I'm going to get a negative and negative, which are going to cancel out, and I'm going to get 1/4 here. And then here, if we just keep this as it is for the time being and just write it like this, the reason why I'm doing this is just to show you that what we have done here is that this 1/4 right here, this corresponds to A1. This region right here would be 1/4. And this one right here, A2, would be negative 1/4. So this right here would be negative 1/4. So the same absolute value, just different signs. But because I put a negative up here, realizing that this was below the x-axis, I anticipated this, and therefore what I'm going to end up with is 1/4 plus 1/4, because my negatives are going to cancel, become a positive, and that means I'm going to end up with 2/4, and that is the same thing as 1/2. So my total area is 1/2, total area. My signed area, so if I came down here and I figured out what my signed area is going to be, well, my signed area is going to be 1/4 minus 1/4, which would be equal to 0. And that would be the same thing as if I did this. If I just found the integral from one point to the other without taking into respect the fact that some parts are above and below the axis. So if I went from 1 to -1, 1 to -1, so 1 to -1 of, now I've forgotten what it was, x cubed minus x dx. So that right there would give me 0, my signed area, where I'm just going from one to the other. All right, so we are finished. Hopefully all that made sense. That is part 3. We only have one more question to go, this one down here. So I will see you in that video. Bye-bye.